guys, you're welcome. Now, when you're talking about intersecting seconds theorem, we're saying that we have two straight lines that actually cuts across a circle. And you see, we have line 1 and line 2. Good. Now, these intersecting lines are at a particular distance to the circle. So let's call that distance A and distance C. Also, the point of intersection of the two straight lines that cuts into the circle are also at a distance from this point of intersection to the point to another point on the circumference of the circle at the bottom. Can you see at the bottom? So that means that we are looking at 4 points on the circle relative to the point of intersection of the two straight lines that cuts across the circle, which is point A, the distance from the point of intersection, point B, point C, and point D. A, B, C, and D. So what I'm trying to say is that the distance from this point of intersection, to this point on the circumference of the circle is A, and the distance from this point of intersection to this point on the circumference of the circle is B, and also the distance from the point of intersection of these two straight lines to this point on the circumference of the circle is C, and also the distance from this point of intersection to this point on the circumference of the circle is D. So what the theorem is saying is that if we have these distances lettered A, B, C, and D, then the theorem says that A times B equals C times D. Rather, AB equals CD. Now, an example. Assuming that this is rather an illustration, assuming that we have a distance from this point of intersection to, let's say these are A, B, C, and D. So the distance from this point of intersection to this point on the circumference of the circle is A, which is 12, and the distance from this point to this B is 25, and the distance from this point to this C is 13, and the distance from this point to this D is 23. So from the intersecting second theorem, we have established that A times B equals C times D. So that's what you see here. That is A, which is 12, times B, which is 25, will be equal to 13 times 23. And if you do the math, you will see that 12 times 25 is 300, and 13 times 23 is 299. So you can see that there is not much difference between 299 and 300. So definitely this theorem is appropriate. Now, what about if we have a secant and a tangent at a particular point? Look at this. The lines are called secants. We have established that, right? And let's see a line that touches the circumference of the circle at just one point. We know from our last class that that is a tangent. So this line actually is a tangent line, and this is a secant line. So we have said that since a tangent will touch the circle at just a particular point, the secant theorem still applies, but we'll be looking at this point as 1. So the distance from here to here will take up our C times D. So that will be C times C. So that will be C squared. So if you have a tangent and a secant, the formula will be A times B equals C squared. I hope I've been able to make some things clear to you about this theorem. And if you like the video, please press the like button and hit the subscribe button as well. Please, your comments I will appreciate.